This is the first in a series of 4 videos where we will analyze the energy performance of a heat pump. These videos will include this first one, where we will analyze the instantaneous values, both the R and the COP. Then, instead of a snapshot, we will extend this to operation over time with the SER and the SCOP. We will move on to a very special seasonal case, which will be that of the process chiller. And later, we will analyze the efficiencies. Although all of these are relative to final energy, this one will be with respect to initial energy. And it's a new and very interesting concept that we will analyze in depth at the appropriate time. My name is Jose Arboleda. I am the Training and Regulatory Manager at KEYTER. To begin, what we need to do is take a specification sheet for a heat pump. In this case, we have chosen a reversible rooftop unit since it can operate in both cooling and heating modes. First, we are going to analyze in cooling mode what the power and consumption data are that it provides us. For cooling power, it gives us the value of cooling capacity, but there is a note, one that we always forget to look at, and that is very important. These power conditions are given under indoor conditions of 27 degrees Celsius dry bulb and 50% relative humidity, and outdoor conditions of 35 degrees Celsius dry bulb. Why does humidity matter indoors but not outdoors? If we analyze it on the psychrometric chart, we'll see that the indoor conditions are based on, that is, the return air that the unit will have is based on 27 degrees Celsius and 50% humidity. Why? Because the indoor unit works as an evaporator, and the evaporator is indeed affected by relative humidity. Whereas for the outdoor unit, which works as a condenser, it is not affected. Therefore, the indoor unit will operate at this single point, while the outdoor unit can operate at any of these points within the psychrometric chart, since relative humidity does not affect it. All right. Taking that cooling capacity, which we already know, we will now look at the power consumed in cooling mode. This cooling mode also has a note 3, which tells you that it is the total power consumed by the equipment. All right, with those two pieces of data, we could now calculate the EER, which also has its note 4, and tells us that both the EER in cooling mode and the COPI in heating mode are to be calculated under the standards of 14.511. In this case, we have the 2018 version, but there are later versions. The version that applies to each unit is the one that is used. What does it mean that we have to use EN 14.511, which was transposed in Spain as UNE EN 14,511? All right, so in order to thoroughly analyze that EER, to properly declare it, we absolutely have to make sure the unit operates under those precisely specified indoor and outdoor conditions. And calculate the EER as the ratio between the cooling capacity delivered by the unit or the energy delivered by the unit over a period of time, since the test involves not just an instantaneous moment, but you have to keep the unit operating under those conditions for a certain amount of time. So as we've said, the ER for cooling mode would be the ratio between the cooling capacity delivered and the electrical consumption of that heat pump operating in that mode. In this case, it tells us that it is 3.25. What does it mean that the 14,511 standard in its test gives us an EER value of 3.25? All right. It means that if we consume just 1 kilowatt hour of final energy directly from the electrical outlet, from the main electrical panel, the heat pump will effectively provide us with 3.25 kilowatt hours of cooling energy. We do a bit of magic, we deliver more energy than what we actually take in. Now, the heating mode operation would be exactly the same, just that everything needs to be carefully switched to heating mode. So, we would have the heating power delivered by the heat pump, but now it wouldn't be under the same conditions as before, which were for cooling. Now the conditions are for heating. What are those conditions? Well, those conditions are as follows. Indoor conditions of 20 degrees Celsius dry bulb. Why doesn't relative humidity affect it? Because now the indoor unit works as a condenser, so relative humidity doesn't affect it. And the outdoor conditions have to be a single point. In this case, 7 degrees Celsius dry bulb with 6 degrees Celsius wet bulb. These would be the points. The outdoor unit functioning at that particular point and the indoor unit receiving return air at any of these specific points on the psychrometric chart. All right, now that we indeed possess both the delivered power, which is quite important, as well as the power consumed, we could calculate the COP. And how is the COP calculated? Well, according to note 4, which is the same as before, The R and the COP will be calculated according to EN 14511. How would it be calculated? Well, it's the same thing. We have the unit operate for a certain amount of time under those indoor and outdoor conditions, and the COP is the same as the ER, but now in heating mode, the heating power delivered by the heat pump divided by its final energy consumption. That's important for when we get into the concept of ETA. Right now, both ER, CR, COP, and CPR for process chillers will always be based on final energy. Okay, now that we've calculated that COP, it tells us in this case that it's 3.21. What does that mean? Well, just like we discussed before, if we consume 1 full kilowatt hour of final electrical energy, the heat pump will then give me 3.21 kilowatt hours of useful heating energy. We're still doing that little bit of magic, delivering more than what we put in. To sum up, and this is the important part I want you to remember, for cooling mode, we'll calculate the ER, and it will be the ratio between the cooling power delivered by the heat pump and its energy consumption while operating in that mode. The COP is precisely the same, but now working in heating mode and always operating under the 14.511 standard. That's the important part. You should know that the 14.511 standard sets the guidelines for these types of tests. Well, that's all for this video. Thank you for your attention, and we'll see each other in the next video where we'll analyze both the SR and the SCOP. These will be the extension of these snapshots to an entire operating season. Best regards.